Hello students, I hope that you are good, well and fine. So you just saw integral, the indefinite ones and the definite ones. You saw their properties, you saw how to evaluate indefinite integrals as well as the definite integrals. You also saw some extra properties for definite integrals. Okay, so you now have some basics, more than basic concept of integrals. Okay, now we will be going to this concept of integration deeply. How deeply? That we are going to the applications of integrals, how we can see the physical phenomena or the theoretical phenomena, okay, uh, from this chapter integrals. Okay, so applications of integral, chapter 8. Okay, so let's see the first thing, which is area under simple curves. So one thing which is given by definite integral is area under the simple curves. Okay, so as you saw, we have studied different definite integrals as limit of a sum and how to evaluate definite integrals using fundamental theorem of calculus. Okay, now we will be considering easy and intuitive way of finding the area but bounded by the curve y is equals to fx, x-axis, ordinate coordinates, which is x is equals to a and x is equals to b. The region enclosed by these all four things, which is the curve, axis and the ordinates. Okay, as you can see or refer this figure, the curve, which is this, axis, x-axis, and the ordinates, x is equals to a and x is equals to b. This the curve which is shaded in blue or covered by the region which is covered by blue, or this area, we will be finding out this area using the integrals. Okay, now as you can refer this figure 8.1, we can think area under the curve as composed of large number of very thin vertical strips. This means, suppose first of all you are having this closed area. Now what you are doing is cutting out small strips which is in shape of rectangles, as you can see here. Yes, this length is, this rectangle length is dx and height is y. As you can see, y is what? Your fx. Okay, clear? Okay, so you cut strips, many strips, okay, and then find the area for single strips again and again and again, and then add them. You will get your total area. Yes, so this is our intuition in this case. Okay, so consider an arbitrary strip of height y. So we are taking height y, width dx, as I have already told you, and area will be what? dA means this area for this single strip. Okay, area means this small single strip dA. Okay, this single small strip area will be what? As you can see, this is what type of two-dimensional figure. It is a rectangle, and rectangle area is what? Length into height or length into breadth. That's it, y into dx. So this means your area, which is dA, will be your y dx. Okay, where y is equals to fx. Okay, so this means for the area of a single strip, vertical strip, will be what? Y dx. Now you have to add them. So clear? So whatever the number of strips you got, just find out the area using y dx and add them. You will get the total area under the curve surrounded by x is equals to a, x is equals to b, ordinates, and also the x-axis. Clear? Okay, so this area is called the elementary area, which is located at an arbitrary position within the region which is specified by some value of x between x and b. Okay, we can also think of the total area of the region between x-axis and the ordinates, and also the under the curve y is equals to fx, as the result of adding up the all elementary areas of thin strips. Clear? As I have already told you. So in integration, how we are going to express that information is total area, this capital A means total area will be what? Definite integral a to b, which represent we are finding out area from x coordinate a to x coordinate b. Okay, dA is what? The elementary area sum from where to where? X coordinate a to x coordinate b. Okay, now dA is what? The elementary area is what? How you can find your elementary area? Y, just multiply y with dx. So now your expression or your integrand becomes y dx. Clear? Or the expression for capital A, which is area under the curve, will be what? Integration, definite integration from a to b fx dx. Okay, now I hope it is clear to you. Now second case can also happen, what? That the area of the region bounded by x equals to gx, y axis, and the line y equals to c and y equals to d. This means, as you can also refer this diagram, what we are trying to say is, what if our curve is like in this form, x is equals to some function of y, okay, and we have to find this area, then how we are going to find? Very simple. The height will be x, yes, y going from where to where? Y is from c to d. Okay, curve is x is equals to gy, and this horizontal strip, as you can see, height is or width is dy and the length is x. This rectangle area will be x dy. Okay, in this case the area will be what? Capital A will be definite integral c to d, because we are going from where to where? C to d. X dy. X is what? Your function of y, as you can see, g of y. Okay, so you have two cases when your graph is like this and you have to find out this area. Okay, or in this case also. So you have the same pattern but the different form, different expression for area. Clear? Okay, I hope it is clear. Let us move next. So one remark also, if the position of the curve under consideration is below the x-axis, suppose here your function fx is above the x-axis, in this case also above the x-axis. What if we consider our graph, our curve, our function below the x-axis? Then what will happen? This means fx is negative. Okay, now other condition remains quite same, which is ordinates from a to b, as you can refer this figure, x going from a to b. Okay, but the only change is the curve now is below the x-axis. Now you have to find the area under this curve. Area under this curve, or area under area surrounded, you have to find the area surrounded by this curve, and coordinates x is equals to a, x is equals to b also, and also this x-axis. So the only region you will get is this. Okay, this blue colored region. So area will be for this will be what? Cut the vertical strips with length dx and height fx. Length dx and height fx. The other things remain same. But what will happen? What will happen is that if you find out this simple integration, okay, you will get the negative thing. But as you know, the area will give you the positive, or area always is a positive thing. This means you have to put extra modulus sign in order to find your area. Okay, so whenever you are asked to find area under the curve or area of a specific region, then please do the or apply the modulus thing. Okay, it is recommended for you in order to get the right answer. I hope it is clear now. Or in general way, suppose you are having this curve like this one. Okay, you are having this curve, then you have to find your area under the curve from x is equals to a, x is a here, from x a to x is equals to b. Okay, surrounded by what region? X is equals to a, x is equals to b, and this curve and x-axis. So you will get these two blue colored region. The area will be what? For this you can directly find, you apply the modulus sign or not, you will get the positive area. But in order to get this area, you have to apply the modulus sign, otherwise you will get some negative value. Okay, after getting this area and this area, you have to add them. If you do not apply your modulus sign for this area a1 as written a1, then this will be some negative quantity, this is some positive quantity. If you add them, you will get some less area, which is not recommended for you. Okay, so please keep this point in your head. Clear? Okay, I hope it is clear to you. Let me just show you some examples. So area enclosed by this circle x square plus y square is equals to a square. You all know what is the area for circle having center A, which is pi r square, which is what? As you can see, pi a square. Okay, clear? So, but as you can see, this is your circle with center 0, center 0 and radius a. Okay, so radius is a, not the center. Center is 0 0, okay, or the origin. Radius with a, so area will be, you all know the area, which is pi r square, which is pi a square. Okay, but here we have to evaluate the area by using the definite integrals thing we just saw. So first of all, without the visualization, if you try to do it, you will find your position in a very difficult situation. Okay, so do not try until you get a rough figure for your question. For example, here, first of all, this is your circle with center origin with radius a. So make it. As you can see, your rough diagram will be like this: center 0 0 with radius a. You are having these points like this. Now you have to find this whole area. Okay, in order to get the area, there are different ways. One way is that find your area for this thing, for only this blue part. Okay, if you get your area for this part, then the area will be the same for this also. The part here in the second quadrant, in the third quadrant, in the fourth quadrant, the same. So you will get whatever the expression here, just multiply it by 4, you will get your final answer. Okay, so now cut your strip, vertical strip with length dx and width dx and height y. Now according to area expression, it will be what? Definite integral from where to where you are going. You are going, as you can see, this blue area is going. Always take from left to right. Okay, always take your limits from left to right. Okay, so 0 to a. Yes, this point will be what? A comma 0. So this is 0 comma 0. So this means x is going from 0 to a. So this means your capital A is equals to definite integral 0 to a. Now what about the integrand expression? It will be what? So y dx. Yes, y dx or fx dx. What is your fx? Fx you have to evaluate, which will be your, I have already told you. So 4 times we are going to multiply it. 0 to a will be our limits. Y dx, y means fx. Fx, from where you can find your fx? Or y must be in terms of x. So how you can find it? Very simple. So y square is equals to a square minus x square. Okay, this means y will be root of a square minus x square. So y will be root of a square minus x square dx. Okay, now you have to just evaluate this integration, that's it. Then you will get your final answer. Okay, clear? So how you are going to evaluate it? Okay, we have already seen particular integrations of this kind. So this will be just nothing but x by 2 root a square minus x square plus a square by 2 sine inverse x by a. Now limits going from 0 to a. Use your what? Second fundamental theorem. Okay. You will get what? 4 times this will be vanished. This will be what? A square by 2 sine inverse 1 minus 0. Okay. This will be vanished. This will be vanished. Only thing remains is this. And this is what? Pi by 2. This is what? Your pi by 2. Yes. And this is a square by 2. This means 4 multiply a square by 2 multiply pi by 2. This 4 and this 2 and 2 will be cancelled. You only left with pi a square, which is we already know, which is pi radius square. We already know the area. We just proved it by using the definite integrals. Okay. I hope it is clear to you that how we approached. Now, what if in this way, in this approach, what we have shown is that the horizontal strip approach, sorry, vertical strip approach. What if we tried the horizontal strip approach? Then what will happen? The same thing we have to do, like what? We have to multiply it by 4. The integration will be 0 to a. Okay, definite limits will be what? 0 to a. And the only thing which change is x dx, x dy thing, which is we have to write our x in terms of y. Okay, f of y, or if you remember, g of y dy, we have to write it. So quite simple. So 4 times 0 to a x dy, which is 4 times 0 to a root of a square minus y square. You will get this from where? X square plus y square is equals to a square thing. Okay, so you know the direct formula for this. You just wrote it. You will get, after applying the limits, you will get the same thing. Okay, I hope it is clear to you. Okay, so here is our visual representation for horizontal strip. So we took what? This horizontal strip with a width dy and length as x. Clear? This x must be in terms of y. Okay, so this is it, and you got the same expression for your two approaches. Okay, which is pi times radius square, which is pi a square. Okay, now I hope it is clear to you. Let us move to next example. Now we have to find the area enclosed by the ellipse x square by a square plus y square by b square, which is equals to 1. Clear? Okay, the same approach we will be applying here. Okay, let me just first of all show you the visual representation, which is this. So the same thing we have to do. We will find this blue area, blue colored area, and then multiply it by 4. You will get the whole area of ellipse given. Okay, now height will be y, dx is your width. Okay, now what will happen? As you can see, area will be from 0 to a. Yes, 4 times 0 to a, 4 times 0 to a, as you can see, y dx. Y must be in terms of x. Okay, so y you can take it from where to where? Y can be taken out from here, which is what? 1 minus x square by a square, or y square will be b square multiply with 1 minus x square by a square. Now apply the roots, so you will get y is equals to plus minus b by a root of a square minus x square. Okay, clear? So you will get your expression as b by a root of a square minus x square dx. Now you know what the direct integral for this, you just already know. So it will be what? 4b by a x by 2 root a square minus x square plus a square by 2 sine inverse x by a, limits going from 0 to a. You know the why reason, because we directly know, or we have already seen the direct integration for root of a square minus x square thing, also for x square minus a square thing, also for a square plus x square thing. Okay, so we just applied here. We also applied the second fundamental theorem here, and you will get what as your answer as pi ab. Okay, pi ab will be your area for your ellipse. Okay, now the second approach by horizontal strip. So the only difference will be what? The limits now will be changed from where to where. As you can see, y in y-axis limits will be from where to where, down to up. When you approach down to up, or you move or from upward, okay, you will get where to where, 0 to b, as you can see. Okay, on y-axis you will move from 0 to b. So limits will be 0 to b. 4 multiply integration 0 to b x dy. This x must be in expression in terms of y, so you must write as 4 times a by b, definite integral 0 to b integration root of b square minus y square dy. And you know the direct formula for this. You will have y by 2 root of b square minus y square plus b square by 2 sin inverse y by b 0 to b. Now apply your limits. You will get what? Pi ab, the same thing. Okay, I hope it is clear to you. The physical representation will be like this. As you can see, the limits will be how. Now if you are confused that how we are going to decide what will be our limits, so in case of x, okay, in case of this, when you take vertical strip, if you take vertical strip, then what you have to keep in mind is that from where in x-axis, on x-axis, from where to where you are taking your region, and consider it from left to right always. Okay, clear? Now in horizontal strips, what you have to remember is from where to where you are moving, first thing, but in down to upward manner. Okay, in down to upward, as you can see, this is your down to upward. Okay, you are moving in this direction. This means first your area is starting from where, 0 on y-axis, and going towards, and the end point for the area will be what? On the y-axis will be for b. Okay, so this will be your 0 to b will be your limits. Okay, in this manner you can decide your limits for horizontal as well as for vertical strips. Okay, now exercise 8.1. We have reached to exercise 8.1. Just quickly see. So find the area of the region bounded by the ellipse. So already we have seen the expression. You can directly put your AB value. A is what? As you can see, is a 4 and B is 9. So 36 pi. I think the answer will be 36 pi. Okay, as you can see. So it will be 4. A is 4 and B is 3, not 9, 3. So it will be 4 times 3, which is 12 pi. Okay, so 12 pi will be the final answer, but you have to go by the convention, which is to evaluate by using the horizontal strip or whatever the approach you like. Okay, so clear? Okay, so what you have to, this is your representation. This is your 2D representation of you, so that you can visualize. So what approach we are applying is vertical strip approach. So width will be dx, height will be y. Limits going from where to where, as you can see, 0 to where, the 4. So 4 times area of this part only. Okay, now 4 times area of OAB. OAB is this small part. Okay, you will get your total area for ellipse. Now area of OAB will be what? Definite integral 0 to 4 y dx. Y you can write from here. It will be what? 1 minus x square by 16. Now 3 root of 1 minus x square by 16. Okay, 3 root of 1 minus x square by 16. Now 3 by 4. simplify the inside thing, you will get 3 by 4 outside the integrand. You will get 3 by 4 multiplied 0 to 4 what root of 16 minus x square, and you know the direct integration for it. You will apply your second fundamental theorem. You will get what, this 3 by 4 multiply 2 root 16 minus 16 plus 8 sine inverse 1 minus 0 minus 8 sine inverse 0. So this will be vanished, this will be vanished, this will be vanished. You only left with 8 pi by 2. This means 8 will be cancelled. You only left with what? Okay, so you only, as you can see, you only left with this a can be cancelled. You only left with 3. So you, for area for that OAB part will be just 3 pi. OAB part will be just 3 pi. Now multiply it by 4. You will get the total area bounded by the ellipse, which is 12 pi. Okay, this must be pi, not n, pi. Okay, just a little typo here, typo error. Okay, so 12 pi will be your final answer. What about this? So the same approach we will be applying here. So, but I'll be telling you the direct answer. What we just saw the formula. So you must get your answer as pi AB. A is 2, B is 3. Okay, clear? Or A is 3, whatever you can replace them. So it doesn't matter. So pi AB, you will get pi times 2 multiply 3, which is 6 pi will be your final answer. 6 pi must be your final answer. As you can see, 6 pi. Okay, now how we are going to get it? Just simple. 4 times area of OAB. Okay, limits going from we are using the vertical strip approach. So limits will be what? For area of OAB, okay, you will have limits 0 to 2. Okay, as you can see, 0 to 2, area of OAB, 0 to 2, 3 times of root 1 minus x square by 4. This means 3 by 2 root 3 by 2 integral 0 to 2 root 4 minus x square. The direct integration will be x by 2 root 4 minus x square plus 4 by 2 sine inverse x by 2. Now apply your second fundamental theorem. You will get just 3 pi by 2. Now multiply it by 4. You will get 6 pi as your final answer for the area of the ellipse given. I hope it is clear. Clear? Okay, let us move to the third problem. You have to choose the correct. So area lying in the first quadrant and bounded by this. So area lying in the first quadrant, you have to just find out the area lying in the first quadrant. You all know. You can also directly know. So the first quadrant area will be the total area divided by 4. Total area you will get from where? Pi r square. R is 2. Yes, r is 2. This means 4 pi will be your total area for this, and for first quadrant it will be just divided by 4. You will have 1. So okay, this means pi. So pi. Clear? Okay, I hope it is clear to you. Now the approach will be, as you can see, pi will be your final answer, but we will be going by the steps. Okay, so area bounded by the circle and the lines x is equals to 0. Okay, x is equals to 0 is this y-axis line. X is equals to x is equals to 2 will be this line. Now the circle, first of all, circle will be like this. Now area bounded by all of these conditions, all of these curves will be this. Okay, as you can see, this shows the 1/4 part of the total area of circle. Okay, so by integration it will be what? The limits going from 0 to 2. Okay, we are using the vertical strip. 0 to 2 y dx. 0 to 2 y dx. Y will be what? Root of 4 minus x square dx. This direct integration is just nothing but x by 2 root 4 minus x square plus 4 by 2 sine inverse x by 2. Now apply your limits. The second fundamental theorem, you will get your 2 multiply pi by 2. This means just pi units. This means option A will be your correct option. Clear? Okay. Now area of the region bounded by the curve. Okay, y square is equals to 4x, y-axis and the line y is equals to 3. Just see it quickly. So area bounded by this curve and the y-axis. Okay, so this curve, y-axis and y is equals to 3. So this area, the gray part, the shaded part, we have to find out. Okay, so first of all, what is happening? So what approach we are applying? We will be applying the horizontal. Okay, so this means limits going from where to where? As you know, from 0 to 3. As you can see, yes, 0 to 3. So limits will be 0 to 3 x dy. X in terms of y, this means y square by 4. So y square by 4. So you know the direct integration for this. It will be just nothing but y cube by 3. Now apply the second fundamental theorem, or just limits. You will get what? 3 cube divided by 3. Okay, like this, and also going to multiply by 1 by 4. You will get 1 by 12 multiply with 27. Simplify it. Okay, or after getting common 3, 3 will be cancelled out. You will have what? 9 in your numerator and 4 in your denominator. So 9 by 4 units. So the correct option will be 9 by 4, which is B. Okay, clear? Okay, I hope that you understood every part of today's session. So what we just did in today's session is how we are going to find the area asked in our question. Okay, or area bounded by curves, lines, axis, all that stuff. Okay, so this is it for this session. Okay, so we will be back with the remaining part of this chapter, which is miscellaneous. Okay, so thank you. We will be back soon.